Good morning, class. Today, as I promised, we're going to do rotations. Uh, so, what we have here, I'm going to make it even shorter and simpler to the point. We already talked about the definition, all that stuff. On the first day, I just wrote down the definition again, two reflections over intersecting lines. And remember that the orientation, if we talk about a triangle or quadrilateral, the orientation will remain the same. Remember, anytime there's an even number of reflections, the orientation remains the same. So the other one is for translations that we did yesterday. All right. Again, you don't have to know that in order to do these problems at all. Just definitions and making sure that you're understanding the concept of orientation, which will probably be on the part for DCAS. All right. So what I have written down here is if you only want to know one way to do all rotations, whether the points at the origin or off the origin, you can follow these steps right here. That's what I'm going to show you here. Down here, I have shortcuts for rotating about the origin. So if it is the origin, which you will have on both your quiz, test, and TCAS, here's shortcuts that you can recall. So for recall, look at this. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Of course, that's the positive direction. Remember, counterclockwise is positive degrees. I could also go 0, negative 90, negative 180, negative 270, and negative 360. If I went clockwise, that'd be negative degrees. So when you're looking down here, it says rotation of capital R stands for rotation. The subscript is the degrees. Rotation of negative 270 degrees. So negative 90, negative 180, negative 270 is right here. Well, you should know that negative 270, same thing is going rotation of positive 90 degrees. That's why you see that right here. Okay. And then here would be the shortcut for it. If you start with xy, wherever the point is, the final answer is negative yx. This is explaining what's actually happening. You're reflecting over the line y equals x following reflection over the x-axis. So if we're talking about this one right here, what's happening is actually happening. You're taking that point, reflecting it over the x-axis, and then you reflect it over that line y equals x. And it puts it up here. If you started here in quadrant 1, it puts it up here in quadrant 2. Okay, so these are the explanations of what's actually happening. Okay, as opposed to just straight memorizing. If you can just straight memorize, that's all you got to do, on the DCAS park and the test. But if they were to ask you what you're actually doing, this is the steps to two reflections. Remember we talked about a rotation is two reflections over intersecting lines. So here's your two intersecting lines that we're talking about here. So that's what's actually happening. But you can just straight memorize the final rotation point and where it'll be. All right. So again, this only works for going about the origin when the origin is center. If the point is off the origin, such as this right here, there is no shortcut for that right here. Okay, so now let's go through these steps right here. This will work for all rotations, including this point off the origin that we're rotating about. So we're going to do all four of these right now, and then you can go ahead and work on your worksheet and choose to do either method. But of course, for this one, you have to use this up here because there's no shortcut for points that you're rotating off the origin. All right, so as it says, draw a horizontal line from the center of rotation. Well, for all these, the center of rotation is the origin. So I'm plotting the point at the origin. Let's change the color here, red. Okay. And I plot the point itself, 3, 5, 1, 2, 3, 1, 2, 3, 4, and 5 right there. So I plot the points. Okay, it says draw a horizontal line segment from the center of rotation. Center of rotation is the origin in all these cases, except for the one down here. So I draw a horizontal line segment from it toward the point being rotated, which is obviously up here. So I'm drawing a horizontal line segment. Then I draw the vertical line segment to connect it, and then I connect it back right there. So when I'm done, you have a right triangle. Notice, again, the key is you must start at the center of rotation and go out horizontally first. You do not go vertically first and go and draw a right triangle this way. You go horizontally first. Okay, so now it says rotation of 90 degrees. We're going to rotate this triangle 90 degrees. How do you rotate the triangle 90 degrees? You look at this horizontal line segment, the first one you drew, and you're going to rotate that 90 degrees. Well, which direction is 90 degrees? 90 degrees is counterclockwise. So this horizontal line segment now gets rotated to a vertical. Right there, that's 90 degrees. The horizontal becomes vertical. Okay, and of course, and that means it's pushing this one forward. This is ahead. This point up here is ahead of this segment right here. It's getting rotated here. So this is going to get rotated over here. Okay, so I count. How many was this? 1, 2, 3. So I am going up. We'll change the color now. Oops, change the color to green. So I'm going up 3. 1, 2, 3. So this segment now is this segment right here. Okay, and of course, then this got flipped back this way. It got pushed forward. So how long was this? 1, 2, 3, 4, 5. Of course, it's 5 right there. So I'm going to count 5 this way. 1, 2, 3, 4, 5 right there. So there is, and if I want to, I can go ahead and draw the triangle. Okay, so this triangle is rotated 90 degrees, and this was my pre-image point of 3, 5. And so now, what is this point right here? Negative 1, 2, 3, 4, 5, negative 5, 3. Okay, and there's my final answer. There's my image right here. Negative 5, 3 would be the answer. Equals negative 5, comma 3. It's a point. Okay, now let's check that with our shortcut method. We're rotating 90 degrees right here. The xy, the 3, 5 becomes negative yx. Negative y is negative 5, and x is 3. And we see we get the exact same answer right here. Okay, so that's the shortcut method. Okay, let's try this one. Rotation of negative 90. So again, it's about the origin. If they don't tell you it's about a separate point, see here it tells you about point negative 3, 2. If they don't tell you that, it's always about the origin. So let's go ahead and plot the center of rotation, the origin, and 2, 5. 1, 2, 1, 2, 3, 4, 5. Okay, and we go ahead and draw a segment. Again, horizontal segment out from the center of rotation, which is the origin, then the vertical up to that pre-image point, and then connect that right there. Okay, now it's negative 9 degrees. Remember, negative degrees is clockwise. So now, again, we're taking that horizontal line segment. It's always going to be this horizontal line segment from this origin here that we're going to rotate 90 degrees. So this from here, 90 degrees puts it right there. So now it's going to become vertical right there. Okay, and let's go ahead and change the color. We'll go orange. Okay, so how far is this? 1, 2. So it's 1, 2 down here, right here. Okay, and then connect that orange. Okay, and now notice when I rotate this to here, this segment is following it. It's behind it. This is out front, right here. So when this gets rotated here, then this one, this vertical becomes horizontal right here. And how far is that? 1, 2, 3, 4, 5. See that here. So again, we're going to go back 5. 1, 2, 3, 4, 5. Right there. And if you want, you can connect that back together for the triangle. The key is this is the point. Okay. So if I ever took a protractor, for example, and measured from a pre-image point to the center of rotation to the image point, this angle right here is always going to be 90 degrees. Okay, since that's what we're rotating it. In this case, negative 90, so that's its direction. If I went from here to here, you can see the corresponding sides, 90 degrees. Okay. If I went from here, I already did that one. Okay. So any corresponding point to its corresponding point, center of rotation, 90 degrees. All right, so what is this point right here? 1, 2, 3, 4, 5, comma, negative 2. So our answer is 5, comma, negative 2. Now, we can check it with our shortcut method here. Rotation negative 9 degrees right here. XY becomes Y negative X. So Y, 5, negative X, negative 2. Right there. Okay? So again, you can choose to memorize this or just choose how to do this method right here. Okay, which of course you would have to do that one for this one down here, but you don't have to do it for these. You can memorize these right here and just plug in the answer. Okay. Okay, rotation 180 means we're gonna have to do this twice. A 90, two 90s, add to 180 as it says up here. So if it's 180, then we do it twice, doing this method. Okay, doing the shortcut method, I can just go right to it. Negative x, negative y. But we want to show this method so you can see this multiple times. So 5, 3. Let's go ahead and we'll go blue this time. 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. And the center of rotation is the origin. Draw my line segment. And of course, we start at the origin. The center of rotation go out horizontally every time. Never vertically, then vertically up to the point. Okay, and then connect it back to the origin, the center of rotation, in this case, the origin. Okay, and what direction does it say? 180 degrees. So it's 90, 180. Or it's the same thing as negative 180 as well, just so you know that negative 180 and positive 180 ends up at the same spot. So we're going to rotate it up 90 degrees and then rotate it another 90 degrees down to here. If you recall from the rotation about the origin from the video yesterday in class, that means it's going to go right through the origin, same distance. So I really could just count this and come right over here, count this, and come down right here the same amount and reconnect them, and there it is. But we're going to go ahead and do it this method and go therefore twice. 90 plus 90 get to 180. All right, so we're going to rotate this up. So again, that means this horizontal is going to become vertical. And how far was that? 1, 2, 3, 4, 5. Oops. And let's just change the color to red. So we're going up 5. 1, 2, 3, 4, 5. And remember, this is when it's getting rotated up, this segment is ahead of it. It's pushing this one. So this is going to be ahead over here. 1, 2, 3. 1, 2, 3. And there's my answer. If I want to connect it right back to there. But here's my, well, that's the 90 degrees. We're not done yet. It's only 90. Okay, remember we're going 180. So this is our first 90, and we do another 90. So again, I'm doing 90 from here. Now, I can sit there and look at it this time, and I'm taking this right here, and I'm rotating it 90 degrees. So this vertical, every time it's vertical, it becomes horizontal. Okay, so this is getting rotated down to here. Okay, and let's change the color. Let's go purple. Okay, so how far is this? 1, 2, 3, 4, 5. So I'm coming out 5 this time. 1, 2, 3, 4, 5. That's this piece here. Now notice when I'm rotating this down 90 degrees, this piece is ahead of it. So it's ahead of it. So it's out here still ahead. How far is that? 1, 2, 3. So 1, 2, 3. Remember, all isometries or rigid motions, remember that means the same things, are always congruent if we're doing a rotation, a translation, reflection, or glide reflection. So all these triangles would be congruent. Okay, and remember that's the definition of congruence. So if I can go from the pre-image to the image with any combination of isometries or rigid motions. So right down here now is my final answer. What is that point? Negative 1, negative 2, negative 3, negative 4, negative 5, comma, negative 3. Okay, and let's check it with the shortcut method. 5, 3, it tells me a rotation of 180. Just change and put the negatives on the X and the Y. There's your negatives, or do the, not negatives, but do the opposite on each. So this is the opposite of 5 is negative 5, and the opposite of 3 is negative 3. There you see your answer. Okay, and that's how you can see about doing it 2 rotation of 90. That's the most you'll ever have to do if you're doing this method, because they're always going to give you multiples of 90. Okay, 90, 180, 270. 360 obviously comes right back onto itself. Okay, or negative 360. All right, last one. So those are all about those first 3 about the origin. Now let's do one that's about a point. It's the same steps that we're doing up here. Okay, remember you have to do this for this one here. There is no shortcut for doing it about here. So it's negative 3, 2. We'll go with red this time. Negative 3, 1, 2, 3, 1, 2. There's my center of rotation. And rotating point 6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay? So remember, the rule is, again, we're drawing out a segment from the center of rotation, a horizontal segment from the center of rotation. Here's my center of rotation. I draw out my horizontal line segment, then do the vertical up to the pre-image point, and go ahead and connect that back right there. And it says to go ahead and rotate this -90 degrees. Remember, -90 degrees is clockwise. So I'm rotating this horizontal down to its vertical right here. Okay. So again, if I just want to draw that rotation, so I make sure that I am doing it in the right direction. I don't go too fast. I make sure I'm going -90 degrees. So there's a negative. Remember, that's why these are all nice. Horizontal to a vertical drawing. How long was this? 1, 2, 3, plus 6 more is 9. So I have to go down 9 here. Okay, let's change that color. Go down 9. 1. Oops. Let's undo that. And I forgot to choose segment first. And now we'll go purple. 9 down. 1, 2, 3. 3 right there. 4, 5, 6, 7, 8, 9. Okay, now notice when I am pulling this like this, my segment back here is trailing it. So it must trail it back 2. Okay, because this is 2, so it's trailing back 2. So here is my image point right there. Okay, and again, if I want, I can go ahead and connect that so I see my congruent triangles. Make sure it looks right, so I actually did do it right. Remember, they better be congruent. Okay, because it's a rotation, and all rotations, translations, reflections, and glide reflections will remain congruent. Okay, so now here's my image point right here. What is that point? -1, comma, -7. Okay, -1, comma, -7. You have to be able to plot your points correctly or identify them correctly. Okay, and there's our final answer. So this is what you're looking to do on today's worksheet with rotations. And of course, this is a video. You can rewind it to watch me do these again. Just remember, the key is, I got the steps right here. After you plot the center, I already assume you could plot the center being the origin of these 3, and then the center being this point here, and the actual point correctly, so I didn't actually write that down. Once you've done that, then you draw the horizontal line segment from the center out and then vertically to the pre-image point in your triangle. And then you're always rotating that horizontal line segment 90 degrees or -90 degrees, depending on what they're asking. Okay, and again, if it was 180, I just do 2 90s to make it 180. Okay, and of course, for these 3, again, like I said, you can use this shortcut method and just get right to the answer right there. So if you don't like doing this, you wouldn't have to do it for these 3, or actually any of these 5, actually. Well, that one, that one, that one, that one, or that one, 5 there. These would be the answers. You have to memorize them. But you do have to do it for about a point. You have to do these steps up here. Okay. And that will end the video. Have a good long weekend. I'm going to attach the worksheet to it as well for those that want to go ahead and do it at home and be ahead and come back when you're working in your groups next class to be able to help out others for those that already understand this from the video. Okay, bye. Bye.